Welcome, y'all. Back to some more geometry. Today we're talking about similar triangles. Now, in the last section, we're talking about similar polygons. So there's a general relationship between all polygons. They have scale factors, similar parts, congruent angles. Now, when we're talking about similar triangles, we're going to involve a lot of things we already did with congruent triangles. Our side angle side, but we're going to use them in a different manner right here. So we'll start with this postulate that kind of sets it all up. Now, it's called the AA similarity postulate. This is just saying that if I know for sure, two angles are congruent from one triangle to the other triangle, then they are similar. Now, this kind of goes back. Let's add some background knowledge. I think back in chapter 3, no, maybe 4. We talked about the third angle postulate. It was a postulate, maybe it was a third angle theorem. It says that if two angles are congruent, then the third angle is also congruent. Okay, and it's because if we know two angles for sure. So let's say this angle right here is, give me a good number, y'all. Let's go with 45. We know this is 45 and this is 45. And then these are vertical, so by default, they're also congruent because they're vertical angles. Regardless what this is, let's say these are also 45. So let's say this is 45 as well, 45, 45. Then what's left, because triangles have a set value, which is 180, subtract the 45s from both sides, so it's 90. You're left with 90 degrees. Well, yeah. And you're left with 90 degrees in both triangles. So by default, that third angle is congruent. So this only needs two angles, but the third angle postulate also says that if you know for sure two angles are congruent to two angles, then the third angle is also congruent because there's only a certain amount of angles a triangle has. So yeah, if you know for sure two angles are congruent, then the triangles are similar. Now, for example, I gave you this right here. I said these angles right here. You were only marked with two angles. Like that angle is congruent to angle. We have to then be mindful, like what is also true? What other things can I assume is true? And vertical angles is something you can always assume. Always, always, always. Okay, you can always assume that right there. Now, if they also mark this as a 90-degree angle, you can also then go ahead and say, hey, all 90-degree angles are congruent because of 90 degrees. So it's a set value. All right, that being said, let's look at this. So here we have two triangles, okay? The question is, what are the two triangles? So let's start with the first one. The first one they're saying is triangle IKJ. So I'm going to do this in, I agree, IKJ. So this is the first triangle. That should match up. And here's the thing. You see these arrows right here? They mean these two lines are parallel. Remember, there's still special things about parallel. We're just going to use those old parts that we learned about parallel lines. Parallel lines have alternate interior angle, alternate exterior angle, corresponding angles, and what was the other one? Alternate exterior angles. Alternate interior, corresponding, and consecutive interior angles. Remember, the consecutive interior angles mean the two angles equal 180 together. So triangle IKJ should be similar to which triangle, y'all? So let's match it up. Angle J right here should be similar to, well, its corresponding angle down here, H. Yeah. And then K should be similar to which one? L down here. Now here's the part that we kind of have a hard time understanding. This angle J belongs both to this big triangle I'm doing in green and also the little triangle that's in here. I'm gonna do half green because it's half green, half blue. It belongs to both triangles here. So we can go ahead and say, hey, triangle IKJ is similar to triangle HLJ. All right, so now that we have similar parts, we're going to see how they're setting up these proportions to figure out its things. As long as the proportion are similar, the proportion of one triangle to the proportion of another triangle, let's see what they're doing. So here they're saying 9. They have the x right here. So x is the corresponding part to its bigger. It is the bigger counterpart to which smaller part. So HL right here, HL is similar to which part? Well, its counterpart would be IJ. ik, sorry, ik. So this will be a 12 right here, and this is x. So that's the first part to figure out what goes over the x. What they're doing here, they're putting, hey, similar part over similar part equals similar part jk over 24. But where's 24, y'all? Where's the 24 here? Remember, that's the sum of the whole thing, because jk is similar to jl right here. jk is similar to jl, the whole thing. So we got to combine that. That's 24. All right, so now that we have our proportions set, our ratio set, and our proportions equal to each other, let's do our extreme means. Let's cross multiply. So x times 9 equals 12 times 24. So x times 9 is, again, 9x right there. 12 times 24 is 288. So 9x equals 288. Now to solve for x, what do we do, y'all? Yes, we divide by 9. X is 32. So that means the value of this right here is 32. Now, we're going to solve for y right here. Now, here is a big one. This is a big one because you will run into the same problem, and we have a hard time doing this. We're still using the 9 and 24. So we're saying this small part to the whole thing. So small triangle to the whole triangle is proportional to small triangle to the what? Whole triangle. Now, what is the value of the whole triangle? What are we going to call the whole thing? It is not 6y, and it's not just y, it's them together. When you together things, it's 6 plus y. That's very important to remember. You're adding those two. Now, because it's a constant number and a variable, you can't necessarily put them together, but you can say it's 6 plus y. And that's okay because we're going to still cross multiply, and it'll cross multiply just fine. And cross multiply those two. So we'll start with the 6 times 24. 6 times 24. 6 times 24. It's 144. So we got 144 equals 9 times 6 plus y. So I'm going to write it just out first. 9 times 6 plus y. Now, make sure you distribute that information right there. So we got 144 equals 54 plus 9y. Okay, and what do we do from here? I'm going to solve for y. So we'll start with, let's get rid of 54 minus 54. We end up getting 90 equals 9y, and then we divide by 9. Y equals what, y'all? 10. Y equals 10. Good. So this is 10. Now, if that's 10, what's the proportion to the whole thing? The whole thing is 16. The whole thing is 16. All right, y'all. But again, the question is, what's y? All right. So that is, again, the angles that are congruent for sure were these two angles and these two angles. And then by default, because they use the same angle right here, then the same angle is always congruent to itself. So that was always by default right there as well. But remember, things about parallel lines, corresponding angles are congruent, alternate interior angles, not alternate interior, consecutive interior angles equal 180. And then, of course, your alternate interior, alternate exterior, but there's no exteriors and interiors here. Okie dokie, y'all. Let's go to the next one. Now, we're talking about the SAS similarity theorem. You can read this, but it's pretty much saying if I can show two sides are proportional, so this side, two sides of over here are proportional to each other, and for sure prove that one of the angles are congruent. So the angles has to be congruent and the sides have to be similar in proportion. Then that proves the triangles are similar. All right. So looking at this, let's kind of look at this. What are we trying to say? What side will be congruent? What side? Here. Well, first of all, let's start with the angle. What's the angle that's for sure congruent? Right here, the one in the middle. All right, so since this is the angle, we have to look at the sides right next to it. We somehow have to show that these two sides right here are similar to these two sides right here. Now, in what order is matter? So the best way to think about it is we got the big number and the small number. So the big number needs to be similar to the big number of the other one over here. And then these two have to be similar to each other. So that being said, we say, hey, our RSQ. We could say triangle RSQ. That's our goal ultimately. Somehow it has to be similar to triangle. If we're matching these up, we also got to match up angles. R will probably be similar than to U. U-S-T. U-S-T. That's our goal right here. So let's try this out. So let's make sure these are in proportion. We got to show that these are proportional. So somehow 12 over 8 should be proportional to its counterpart 9 over 6. 9 over 6. Is that true? Well, let's check. If we reduce this, what do we get? We reduce it by 4. This ratio will be 3 over 2. Good. Over here, we're going to reduce by 3. We get 3 over 2. Hey, we keep the same scale factor, so we are good. They are proportional, so we can go ahead and verify this as to be true. That is true right there. Now let's look at this next one over here. We're going to go ahead and assume this right here. All right, so same thing right here. Similar, we got to find the angle that should be congruent, and then the two sides right next to that we're going to try to prove are proportional. We're going to see the proportionality here. So this is a right angle, and again, these two angles are adjacent. All adjacent angles are on a right angle are also right. So this triangle right here, and it's going to be kind of, I'm going to do this one blue. This triangle right here, we have to show that somehow is proportional to this triangle over here. So they're going to share one side right there. So let's see how this side is related. If I were to kind of stand this light blue triangle up, P, N, L, so we'll go P, N, L, this will be our 25, and this will be our 15. Now comparing it to this over here, our smaller one, L, N, A, L, right angle, and A. This is how it should match up. This is our 15 over here, and this is our 9. So the goal, we have the angles, and these are the two sides right here. This side, and then on this triangle, it'll be this side, it'll be these two sides right here. These are the two sides next to the angle, and these are the two sides next to this angle. So we know that for sure the angles are congruent, so we got the A part down. So we're good on the A. Let's look at these two sides. So we're going to say, hey, 25. I'm going to do long side to short side, 25 to 15 should be proportional to the long side to short side of this one. Long side, 15. Short side, 9. So let's see. You can cross multiply and check it that way, but let's go ahead and reduce it first. What can these reduce by 5? These reduce by 5, so we're left with 5 over 3. These reduce by 3. These reduce by 3. You're left with 5 over 3. Look at that. They are proportional to each other, so we got our side, our angle, and our side right there. So we can go ahead and assume triangle P and L. We gotta make sure we match up the angles. P and L is similar to triangle L and A. And so as you go through this homework, and they're asking you like, hey, are these triangles proportional? You're gonna check either or similar. Check. Hey, can I prove that two angles are similar to each other? Yes or no? Yes. Or can I prove that two sides and the angle in between is similar? Like here, we couldn't prove that R is similar to U, Q is similar to T, but we can automatically assume this. And then because we have the sides next to it, we can go ahead and say, hey, these sides should be proportional as well. And if we could show proportionality, we can. Now, when I did these right here, I did the big side over the small side on the same triangle. You can, and I'm gonna erase this right here. I'm gonna use the same triangle over here because I like this triangle. I'm doing a different color so we know what we're doing. We can put similar parts to each other over each other and see that reduce the same way. So we do 12 over 9 and then 8 over 6. You got to make sure you do the same thing. If I'm doing big triangle to small triangle, then I'll do big triangle to small triangle. So 12 over 9 should be similar to 8 over 6. Let's reduce that. Let's reduce the same thing by 3s. we're left with 4 over 3, and this will reduce by 2's. That'd be 4 over 3. So yeah, they still keep the same scale factor here. So we're still good, the same proportionality. All right, so you can do it that way as well, as long as you do, if I'm going big triangle to small triangle, big triangle, small triangle. You can also go big side to small side, big side to small side in that case. Last one here. So the SSS similarity theorem. This is probably, to me, seems the most common, like the most like obvious one. If I can show that all 3 sides of one triangle are proportional to all 3 sides of the other triangle, then the triangles are similar. We're trying to prove there is some similarity here. So the best way to kind of look at this is say, all right, the 3 parts right here are 10, 15, 20, 16, 24, 32. So the best way to do this is let's match them up. Let's take small to small. We're going to do small to small. And I put these lines not because they're congruent, but just kind of show these are the parts we're comparing right here. And then medium to medium, large to large. And then that should also match up when we try to do the similarity statement. And again, the similarity statement is saying, hey, triangle, blah, 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 is similar to triangle, blah, blah, blah. This is the similarity statement. So when they ask, hey, tell me the similarity statement, you're saying, in what way are these triangles similar in the right order, letter-wise? So let's double check. So we're going to do 10 over 16, 15 over 24, and 20 over 32. They all should hopefully reduce to the same thing. So right here, we can reduce by 2. We're left with 5 over 8. Here we can reduce by 3, right? Yep. We're left with 5 over 8. Here we can reduce by 4. Divide by 4, divide by 4. We're left with 5 over 8. Hey, all 3 proportions, all 3 corresponding sides do reduce to the same scale factor, 5 over 3. So 5 over 3, 5 over 3, 5 over 3. Oh, 5 over 8, sorry, 5 eighths. 5 eighths, 5 eighths, 5 eighths. So then, let's go and match it up. I'm going to go small side, medium side, large side. So F, H, G. So F, H, G should be similar to triangle. So we're looking at triangle right there. Triangle, small side to medium side. So X, R, S. X, R, S. So even though this is upside down and flipped over, you can still kind of see how it matches up proportionally. All right, next one over here. Now these, they're sharing a side. So remember, this side, this 24 belongs both to this triangle over here and the triangle it's in right here as well. So same thing, we're going to eventually say our similarity statement. Similar to triangle blank, blank, blank. So let's do the same thing. Let's match these up. So we're going to go ahead and do 16. And then the small side over here is what, y'all? On this triangle, it's the 24. Yeah, 24. 20 to 30. And I'm going to kind of change the color here. 24 of the small triangle is to 36 of the big triangle right here. That should match up, small, medium, large, small, medium, large. So we'll do 16 is to 24, 20 is to 30, and then 24 is to 36. So let's go about this. So here we can reduce by 8. 8 goes into both of them. 8 goes into 16 2 times. 8 goes to that 3. Here we're going to reduce by 10s. So 2 or 3, all right, so we're doing good. Here we're going to reduce by 12. Or less 2, 3 over, that 3. 12 is 2 over 3, yes. So we show all 3 sides are proportional to each other. So same thing, we're going to go small, medium, large. So C, D, A. C, D, A is similar to C, A, B. C, A, B. All right. All right. So one more example. So this is for you guys to do. So it's kind of go. So pause, read this, and try it out now. The 2 triangles. This triangle, and then the whole thing. Remember, those are the 2 triangles we're trying to show similarity here. All right. So hopefully you went through this and tried it out. So Cecilia here, she wants to find the height of a certain tree for a report in her English. Her method is using the shadow as shown in the diagram. So she's standing right here. Her shadow's casting all the way over here. And then the tree shadow also casts over here. So this is the distance of shadow right here. Now she's measuring this the shadow in the tree, and she found the shadow of the tree is 5 meters long. So from here to here, that's 5 meters long. She measured her shadow, and that's 0.8 meters long. And her height, and I forgot to put in here, her height is, let's go, 2 meters. She's 2 meters tall. That's like 6 something. Man, she's a tall girl. So it says she's 2 meters tall. What is the height of the triangle right here? Now, are these triangles similar? First off, yes, they both share this angle S, and they both have a 90-degree angle right there. So they are similar. There's our angle similarity. So they are similar. So this should be proportional to each other. So when you're setting a proportion, just like anything else, I'm going to say, hey, side to side, which is the whole thing, equals side, her height, to this side right here. Oh, I used the wrong color. I'm sorry. So let's go ahead and set that up. I'm going to go 0.8. So small triangle base is to 5, as her height 2 is to what we're looking for, the tree right here. So we cross multiply, we get 0.8x equals 10. And then we just go ahead and divide. So 0.8. So we divide both sides by 0.8. Now make sure you do this because it's not going to be like it's 10 divided by 0.8. Don't forget that point in front of the 8. That gives us 12.5 meters. That's a tall tree. That's how tall the tree is right there. All right, hopefully we got the same answer, y'all. Y'all have a wonderful day. See you on a different day. Bye.